Welcome to the deep dive. You send over some really vital information on excavation safety standards. Our goal today is to kind of unearth the crucial safety considerations. It's easy to forget, the sheer power of the earth.
Oh, absolutely.
A single square meter can weigh 1.3 tons, and that figure swells by 30% when it's waterlogged.
Right. It's staggering.
That kind of weight. Well, a collapse isn't just being buried. It's like being hit by a car, and it happens in seconds.
Instantly.
Which is why the first OSHA codes for excavation safety appeared way back in 1971.
Exactly. And just to be clear from the start, the material you shared distinguishes between an excavation, where the width is greater than the depth, and a trench, where it's the other way around, depth greater than width. This distinction is pretty key because, well, different situations demand different safety approaches. Let's start with the ground itself.
Okay, yeah, let's unpack the soil. What makes it behave the way it does?
Well, what's interesting is how we classify soil, as its stability directly dictates the safety measures needed. We generally talk about four main types. Rocky soil, which is the most stable. Then type A, that's cohesive, meaning it has a good amount of internal stickiness, like modeling clay.
Right.
Think clay loam with a strength of 1.5 tons per square foot or more.
Okay.
Then there's type B, also cohesive, but less strong, maybe 0.5 tons per square foot, like silt or clay.
Got it.
And finally, type C. That's the least stable, less than 0.5 tons per square foot.
Yeah. Like
sand or, any water-saturated soil.
And as the information points out, these aren't fixed categories, are they? Water, vibrations, even a crack can change things instantly.
Precisely. Soil conditions are dynamic.
Which leads us directly to the dangers on a work site.
Yeah.
Where do we even begin with excavation hazards?
The most frequent and definitely the most severe hazard is a cave-in or engulfment. Given those soil weights we just talked about, the risk is immense. Your materials highlight factors like moisture, previously disturbed soil, that's a big one, vibrations from equipment or traffic. The weight of equipment or excavated material too close to the edge, that's what we call surcharge loads, and even just mixing different soil types in the same dig.
That's a chilling thought, a cave-in. What other major risks are lurking on these sites then?
Underground services are a huge concern. I mean, hitting electricity cables, that can cause fires, explosions, electrocution, damaging gas or petroleum lines, or, risk leaks, massive fires. Then you have communication cables, water lines, which can cause direct injury, flooding, and totally undermine stability.
And sewage?
And sewage lines, yeah. Hazardous gases, contamination. There are even less common lines carrying toxic gases or inert ones like nitrogen, posing asphyxiation risks. It's like this hidden web of potential danger just below the surface.
Absolutely. And it's not just what's beneath the surface, right? The excavation itself can become a confined space.
Correct. Any excavation 1.2 meters or deeper is considered a confined space. Why? Because entry and exit are limited, and heavier than air toxic gases can pool at the bottom.
Right, especially in places like petroleum facilities, I imagine.
Yeah, exactly. Gas detection becomes critical there.
Makes sense. What about some of the more, maybe obvious dangers above ground?
Yeah, falling is a significant risk. People falling in, equipment, even the excavated soil itself can slide back into an unprotected hole.
Okay.
Even the tools themselves pose hazards. Manual handling injuries, sure, but also equipment strikes, crushing incidents, vehicles rolling over or hitting overhead power lines.
Oh yeah, overhead lines too.
Definitely. And vehicle movement near the edge adds to that surcharge load risk we mentioned.
Right.
And, don't forget, less obvious dangers like flammable gases may be collecting in low-lying areas, or even things like reptiles and scorpions in certain desert environments.
Hadn't thought of scorpions.
It happens. Plus, damage to nearby buildings from undermining the foundations, issues with groundwater affecting stability and posing drowning or electrical risks, and encountering contaminated soil, all critical hazards.
It's a long list of potential problems. Thankfully, there are ways to mitigate these risks, especially cave-ins. What are the key protection systems we need to know about?
So there are three main ways, basically, to protect against collapse. Sloping or benching the walls, using shoring systems, and using prefabricated shields like trench boxes. And the key thing is, whatever method is used, it must be strong enough to handle the expected forces, the soil pressure, the water, everything.
Okay, let's break those down. What's the idea behind sloping and benching?
Okay, sloping just means cutting the excavation walls back at an angle away from the hole. The safe angle depends entirely on the soil type. Almost straight up, like 90 degrees for stable rock, but much gentler, maybe 34 degrees for unstable type C soil like loose sand.
Okay, so it varies a lot.
It does. Benching involves creating horizontal steps or benches in the excavation walls. Again, there are specific rules limits on the height of each step, depending on the soil type and the overall depth of the trench, generally up to 6 meters deep for trenches.
So it's about creating a stable shape naturally or in steps. What about shoring? When would you use that?
Right, shoring is a support system you use when sloping or benching just isn't practical.
Yeah.
Maybe the space is too tight or you're right next to a building foundation.
Makes sense.
It's used to hold back potentially unstable soil or protect existing underground utilities. It typically uses things like vertical posts, horizontal braces, and sheeting like plywood or metal plates to form a wall.
Okay.
There's also hydraulic and pneumatic shoring, which are pretty neat because they use pressurized cylinders and can often be installed and removed remotely, keeping workers out of the trench during that process.
Safer.
Exactly. And for cohesive soils, you might also see aluminum or steel soldier sets or piles driven in.
And those trench boxes, the prefabricated shields, you hear about those a lot.
Yeah, trench boxes are a really effective protection method. They're essentially strong, rigid boxes, usually steel or aluminum, that get lowered into the excavation.
Okay.
Workers then operate inside this protected space. The crucial thing is to keep the gap between the outside of the box and the soil wall as small as possible. And often you need to backfill that gap to prevent the box from shifting.
Right, so it doesn't move around.
Correct.
Yeah.
They can even be used together with sloping or benching. And if there's a slope nearby, the top of the box needs to extend at least 45 centimeters above the surrounding ground level for added protection.
Okay, so having these systems is vital. But what about the actual work itself? What safety steps happen, before, during, and after the digging?
Absolutely critical. Thorough planning beforehand is everything. You need to know the soil type, locate all the underground and overhead services, identify nearby structures, understand the groundwater level, consider traffic patterns, check the weather forecast.
A lot to check.
It is. And you must appoint a qualified, competent person to oversee the work. Regular inspections are mandatory, step by step. Only properly trained people should operate the heavy equipment.
Right.
And the site itself needs to be secured. Clearly marked with barriers, like safety fences, ideally set back about 1.5 meters from the excavation edge. And if you're working at night, proper lighting is essential.
Okay, that's before. What about during the excavation?
During the actual digging, maintain safe distances. If someone's digging manually, keep them at least a meter apart. Heavy equipment needs to stay at least 3 meters away from any overhead power lines.
3 meters, okay.
Use spotters for equipment operators to help manage blind spots. Crucially, always try to excavate beside, not directly over, known underground services if possible. Use careful hand digging when close.
Gentle approach.
Very gentle. Make sure any walkways across the excavation are stable, at least 60 centimeters wide, and have proper guardrails. Keep the whole work area tidy. Good housekeeping prevents trips and falls.
Makes sense.
And for deeper excavations, say 1.2 meters or more, especially around petroleum facilities or potentially gassy areas, you absolutely must test for hazardous atmospheres, oxygen levels, flammable gases, toxic gases like H2S. Daily checks minimum, often continuous monitoring is required.
Continuous monitoring, why?
It can be necessary. Also, keep that excavated soil, the spoil pile, back from the edge, at least 0.9 meters away, or 1.5 times the pile height if it's taller, whichever is greater. And don't pile it too high, generally max 0.6 meters to prevent overload and it's sliding back in.
Got it. And PPE, of course.
Always. Hard hats, safety boots, high visibility clothing are standard. Other specific PPE might be needed depending on the task.
Okay. And then once the digging is actually done, what happens after?
A proper handover is key, especially if work continues over shifts or involve different teams. Document everything clearly. Permits closed out or transferred, what work was completed, what's still ongoing, any future plans for that area, any incidents that occurred, and any problems encountered during the job. Communication is vital.
Right, thorough documentation. The information also briefly listed the types of equipment often used: excavators, dump trucks, bulldozers, rollers, loaders, graders, vacuum trucks. It really highlights how complex these operations are.
It really does. There's a lot of heavy machinery, a lot of moving parts, and a lot of inherent risk if things aren't managed correctly. It's all about understanding those potential dangers at every single stage and consistently putting the right protections in place.
So as we've discussed, safety in excavation is it's paramount, non-negotiable. Knowing these standards from the material you shared is clearly the essential first step in preventing serious, potentially fatal incidents.
Absolutely. It forms the foundation of safe work.
Here's a final thought then. Considering how interconnected all these safety measures are, how a breakdown in that initial planning phase can easily create a domino effect of risks right there on the site.
Good point.
Beyond these essential standards we've covered, what additional proactive measures might you consider for really complex excavation projects? Something maybe to further enhance safety, just something for our listeners to mull over.
That's a great question to ponder, thinking beyond compliance.
Exactly. Well, thanks for exploring this really critical topic with us today.
My pleasure. Stay safe out there.